This example is really different because it's really kind of it's a full-blown complete example that we just have a small part to add. And so, in fact, this when I was early teaching this class, in the 2007, 2008, something like that, I used to build this example up over several classes. We used it for user forms. There's an add tickers form here that we did various things with user forms here, but I don't really use this example anymore. But here's what it is. It's a portfolio optimizer. The idea is you supply a set of tickers, and then this code will do the rest to say, that's what you want to invest in. You're going to tell me what your expected return is, and then it's going to balance the portfolio to minimize the risk to give it your best shot at getting that expected return with a minimum amount of risk. So that's the purpose here. And it starts with the tickers and it goes and gets the data. Now, turns out finance.yahoo.com used to just make historical data freely available as fast as you consume it, and they quit that a couple of years ago. But I had to find another place to be able to get the data. And so there's a place called alphaadvantage.co that gives a free API to historical data, but it's limited. So you can only get 5 requests a minute and a maximum of 500 requests a day. So if you all hit the get data right now, you would all try to use this API key, and literally we only get a total of 5 requests. We need 1 request for each one of these tickers. So it wouldn't work at all because it'd be trying to get the data too fast. So if you really want to run this right now, you can just go and sign up for your own API key at Alpha Advantage and drop that API key in here, and that way it'll isolate your usage just to your account. And the code is set up to delay so that it doesn't outrun the capacity of the API key. Well, the whole idea for an API key is it says, oh, you're making requests. We want to be able to identify those requests back to your account, so we know you're not abusing it. So I've split this so that get data is one process and it goes and pulls the data in. But then once it gets the data, it would look like this. Getting the data, so here's one sheet of historical data, and it gives us the date, and I'm asking for the closing information at the end of each month. So it's got 4/17 because it's the closest to the end of April that we have, and then last trading day of March, February, January, December, and so forth. And so we've got like the close, and this column then is the adjusted close. This is the volume here, but all we're really interested in is we're interested in the month-over-month percentage change. And so what this says is that this is Southwest Airlines. It says, whoa, maybe that one's no good because it's going from, yeah, that probably is good. 50, yeah, over that month, it lost 7%. It lost 1% the month before. It gained 22% the month before. How could you gain 22% in a month? That's what it did. The stock went up 22% in that month. And so we're using this month-over-month percentage change to get a sense of the volatility of the stock. So how volatile is it? We're then consolidating that information for each of the top stocks that we have picked. So that's all we have here really is the month-over-month percentage change. We're then summarizing that. We can get a correlation matrix here that tells us how closely correlated these are. So who's highly correlated? I'm seeing 3. So here's a 0.36. Where's 0.4? Here's one. IBM and ExxonMobil are 0.422, 0.44 GE and ExxonMobil. Is there one higher than 0.44? Oh, here's 0.5. Oracle and ExxonMobil. Kind of surprises me that those are so highly correlated because Oracle technology stock, ExxonMobil an energy stock. But it's just saying that's when the one tends to go up, the other one tends to go up. When the one tends to go down, the other one tends to go down. So in terms of trying to figure out how to allocate the portfolio, we're going to be looking for things that have low correlations or even negative correlations. I don't see any negative correlations. That would be great if we had some negative correlations in here. So when we have a low correlation, that means there's little connection in terms of when one goes up, the other one goes up. And so that's going to help us to kind of balance this out. And so here's the model then tab. We now have the covariance matrix here, which is going to allow us to get a single measure for the portfolio variance. So standard deviation and portfolio variance are both measures of the volatility of this basket of stocks when we look at them together. One's just the square root of the other. But here then is where we're actually allocating the bundle. So up here we've got weights. I have 10 stocks. They're equally weighted right now. So each of them is pushed at 10% of the 10% of our funds are going into each one of these stocks. But then here is the average month-over-month return. So American Express looks like on average for the time period that we're talking about, which I think is like from 2012 till today, not a bad time to estimate the near future. 1%, 1.1% month-over-month increase. Apple, a 1.6% month-over-month increase. Southwest Airlines, a 0.24% month-over-month increase. General Electric, on average, has lost money over this period. I shouldn't say on average, but the average month is a decrease of 0.1%, or 0.16%. Okay, so that's what these numbers mean. So the whole idea here is that we need to say, I'm going to try to figure out how to reduce my portfolio variance. So here I have my portfolio variance, 0.001. Let me just copy that and paste it so I can use that as a benchmark. Paste values. So I'm going to make a change in the weightings and see if I can reduce that variance. So who was highly correlated? It was Oracle and ExxonMobil. So let me take some out of ExxonMobil and put it somewhere else. So I'll move ExxonMobil down to 0. I'll put Southwest Airlines up to 0.2. And did that decrease my risk? That looks like it increased my risk. So I went the wrong way. So maybe I'll flip those and put Southwest Airlines down to 0, ExxonMobil up to 0.2. And that's decreased my risk. So hey, great news. I just decreased the risk. So that's what we're trying to have happen here. We're going to kind of guess and check, make small adjustments in how we're allocating each one of these stocks and try to minimize that risk subject to two different constraints. The first constraint is that we're going to try to get our expected return. So this is just from the formula here. It's the expected return based on how we've allocated this portfolio. We want that to be greater than or equal to a return that we're expecting here. So let me just put this in at like 0.01, so 1%. And we've got to allocate the whole portfolio. And so the sum of our weights, which is the formula right here, that's got to sum up to 1. So if I take some out of one of these, I've got to put some into another one. And so this is what Solver was built for, right? It's to be able to say there's no analytical solution here, but let's just plug some numbers in and we'll see how the formulas converge and come up with the best thing that we can figure out. Okay, so how many of you are kind of looking at this saying, this is a pretty simple Solver model, I'm familiar with Solver? In fact, maybe even show on a scale of 0 to 5 how familiar you are with Solver. I'm seeing 4s, 5s, 4s, 5s, lots of 4s and 5s. And some folks who aren't voting, maybe they're checking their email. Okay, so yeah, I mean, it used to be that when I taught this, step 1 was, let me explain to you what Solver does, but it sounds like you're picking Solver up in other places now, which means we're probably going to get done early today since I don't have to teach you what Solver is. Here's what we're going to do. We are going to configure Solver once to run this model. Then we're going to record ourselves configuring Solver, and then we're going to go look at the code that it records and see what it does. So let's go ahead and go to Solver, which is on our Data tab. And the Solver, of course, Solver is an add-in, so it might not be here. So if you don't have Solver, let me know, and I'll help you. I'll see where you can get it, but I'm guessing you probably all have Solver already loaded. We'll open up Solver, and we'll go ahead and specify this. So my objective cell is going to be my portfolio variance, D12. I'm going to make that to a minimum by changing all of my weights subject to a couple of constraints. I'm going to add a couple of constraints. First constraint is that the sum of weights has to be equal to 1. I'll add that constraint. And second one is that my expected return, which is in D10, needs to be greater than or equal to my required return, which is in F10. We've got unconstrained variables, non-negative, so we're not going to be trying to push any of these things below 0. And so that looks a pretty good model. We're going to use the default engine here. I couldn't tell you why to choose one over the other anyway, so let's go with the default. And we'll solve. So solver is going to run through, plug in a bunch of numbers, make small changes, and do it thousands upon thousands of times. It says it found a solution. I'm going to say, OK, we'll keep the solution. And so now we've gotten our expected return now is even a little bit above the 1% return that I asked for. And we took our risk down by a little bit from 1300ths to 1100ths on the portfolio variance. So it says we don't want Southwest Airlines at all. But the rest of these we want a little bit of. And there you go. Who did it give us the most of? Looks like 23%, 27% at cost. Is that Costco? I don't know. I don't know who that is. Okay, so that's the whole point, right? It's done all that checking that took me probably a good 15 seconds to make one flip. It's done it thousands upon thousands of times. Okay, so I think we're ready to record ourselves doing that. So I'm just going to start recording a macro. Macro 1 is a great name for it, and I don't need a description. We'll just start recording. I'll come back to my solver. So data tab, solver. Oh my goodness, it's already configured. But we got to record the code that says make all these changes. So we're going to start off by resetting everything. So we'll hit the reset all button. It clears everything out. And we'll go through that process again. We'll set our portfolio variance as the target, as a minimum, by changing the weights subject to the constraints that my sum of weights has to equal 1. And my expected return has to be greater than or equal to my required return. I'll go ahead and say solve, keep the solution, and stop recording. Look at the code. Okay, so I've got module 1, module 2. Module 1 is the code that we already had built for this whole example. Let's go to module 2. So here's what we just recorded. Now, how many of you, by a show of hands, have ever looked at the code that the macro recorder recorded and said, wow, that was a really weird thing to record? Looked at it and said, I don't think I'd have done it that way. Yeah, I think we've all had that experience. Well, it turns out, as you know, Solver is an add-in, meaning it's not written by Microsoft. It's written by a company called Frontline Systems. They also wrote the macro recorder for the Solver as well. And if you thought Microsoft did things weird, get ready, because this is even weirder. First one here that we see isn't too bad. Solver reset. I'm just going to reset the Solver. But you're going to notice this is not any kind of object, right? It's not object.method or anything. It's just a statement. And so how many solvers, by the way, how many solver models could I have in my workbook? What's the limit? There is a limit. I'm not surprised that you don't know it. It is 1 per sheet. I think there's a limit on sheets. I think the limit on sheets is 255 sheets. But the point is, I can have multiple solvers. So when it says solver reset, which solver model am I resetting? How does it know which one to reset? Yes, the active sheet. You can only have one solver per worksheet. And so this is going to be the one on the active sheet. And so step 1, let's make sure that we have activated the sheet that we're going to be working on. So that doesn't get recorded, but let's go ahead and do that. So this workbook, dot worksheets. The worksheet that has the model is called model, and let's activate it. All right, then we'll reset the solver. It says whatever was there, let's get rid of it. This is important because you could, if you're like making a workbook, you could just get the solver all set up. The solver remembers how it's set up on that worksheet, and then the next time you run it, the solver configuration could just be there. But the reason you always want to reset the solver if you're going to work with it through code is because some user could go in and fiddle with it. And so you want to say, I don't know what was here before, but blow away anything about that solver configuration and let's get it set up so that we know what we're working with. All right, let's look at this next step, which is the solver OK statement. This one, I think the name is strange, solver OK, but the parameters aren't too bad. So set cell D12, that's our target cell. Min max value equals 2. What does this mean? What does 2 mean? It means minimize. What was we told it to minimize? Well, how do I tell it to maximize? I don't know. Record yourself choosing maximize, it'll tell you. It's probably 1, but you can do that. You can also set it to a value of, and if you've got the max min val set to mean the value of, then the value of becomes meaningful, but for us it's not. Now, here's the first one that becomes a little bit of a problem. By changing B4 to K4. Why is this a problem in the context of this current application that we're building? Think about kind of what this thing does. If you're going to kind of start from scratch, what could make this break? Go ahead. Right. So just to repeat the question, this thing is set up right now for 10 stocks, and that's what we have between B4 and K4. We've got 10 cells in there, but what if we change the number of tickers in our basket? This thing has to be dynamic. And so we can't just leave this hard-coded. We've got to do something to tell it to figure out, oh, don't end with K4. You know, we could go to the end of row 4 and then come back in until we bounce into that. But as it turns out, when I wrote the rest of this project, when we built that part of the model, I named that range. And so we have a named range that is automatically going to be the right size. And it's called weights. So, but this is something that I have to anticipate for the model, because as the model changes sizes, this part has to change. And we're saying to use the default engine GRG nonlinear. That looks great. That one's not so bad. So here's the next one. We've got a solver add, cell reference G7, relation 2, formula text equals 1. Which constraint is this? Yeah, sum of weights has to equal 1. This one looks great, except it's busted. I don't know why it's required, but you'll notice this is called formula text here. This actually has to be a formula. You've got to put an equal sign in front of the 1, or it won't work. Would you like to know how long it took me to find that the first time I was doing this? A long, long time. A long time. I think I finally found somewhere on the internet where someone showed an example. Wasn't saying, by the way, you have to have it this way. It's just like, oh, there's an equal sign there. I put that in, and oh my gosh, it worked. And then I was like, oh, it says formula text. It should be a formula. Okay, now we have another solver OK. So what's different about this solver OK than the one before, or for that matter, the ones after? Just exactly the same. I have no idea why it's there, and it doesn't need to be here. So we'll delete this one. Yeah, but I'm guessing you have a couple other solver OKs down here anyway, don't you? Yeah. So, yeah, so why they're putting it in multiple times, I don't know. It doesn't hurt to be there, except that we changed this first one and it would override it with these others. But here's the next constraint. Again, it's the same situation. We just need to put this in as a formula. We've got a couple of more solver OKs we can get rid of. And then we've got solver solve. So this code's a little bit simpler than it first looked when we recorded it, primarily because it's got all the solver OKs. But you do have to add the equal signs in the formula text. Okay, so that looks pretty good. Let me just go ahead and kind of push this off to the right. And I'm going to bump this back down to 0.1, just equal weights. And I'm going to run my macro 1, and it should reset the model. It should go through this and solve it. Let's take a look. Keep the solution. Yeah, it adjusted all those weights, put them back the way they were. Wonderful. Now, in terms of this workflow, what do you dislike about it? I wonder if you dislike the same thing I dislike about it. What is it? You still got to click on the OK. Solver results, you got to click OK. If only there was some way to tell it not to do that, and there is. Solver solve takes a parameter called user finish. It's a Boolean value. It can be true or false. And this will control whether that dialog box shows at the end or not. So what do you think I should put here? User finish, true or false? I agree. User finish, false. Unfortunately, it's true. User finish false would do exactly the same thing we had before, but now when I do that, it will run the model and just show it without putting the final dialog box. So that's pretty good. So I've now got the solver solving this. The problem for this particular setting is that we got to give some way for the user to tell us what's the required return. We don't know that. We know a range for what the required return could possibly be because we can look at this whole portfolio and we've got a minimum and a maximum return there. Right? So we can't expect to get anything less than our lowest return. We can't expect to get anything more than our highest return. So we've got a range in there, but we don't know which one the user wants. And so in this case, we're ready to kind of get things configured, let the user type in the value they want here, and then hit optimize. So let's go ahead and integrate this code that we've written into the existing solution. I'm going to take the first, well, I'll take the whole thing. Take all the code here, and I'm going to bring it back to module 1, and I actually have two different procedures that are stubbed in here. One is called run solver, and one's called config solver. I'm going to paste into config solver and then cut the second part of this out and bring it into run. Oops, no, I did that wrong. Back up. I only need the very last part here. Everything is configure except for solver solve. But just as, and the same as I have to have my worksheet with the solver on it activated to be able to configure it, I also need to be sure that it's active to be able to solve it. So now I have two different, one that configures a solver, and the solver is now configured, so I don't have to keep configuring each time I run it, but now I can run it multiple times. And in fact, this button that's here on this sheet, and this sheet gets generated automatically, but this button is already set up to run solver. And so I could come here and say, you know what, I don't need a whole lot out of this. I could do something low, like maybe 0.05%, 0.005%. What's the optimal, what's the lowest risk I can get and still achieve at least that? And so let me go ahead and set my weights back to 0.1. Want to make sure that that is executing. So I'll optimize, yeah, and that adjusts it. It says, 0.005, you're really underestimating what you can do here because at the lowest point that we can get that risk, we're even getting more return than that. So that's pretty good. Well, the user might say, well, maybe I'll take a little more, maybe 1.5%, 0.015. And solve that. What do we get? Something a little bit different. IBM and GE drop out. That we've taken on a little more risk, but we're getting a little higher return. Questions so far? Well, what this code does is it goes one level further, and it says over here we've got an efficient frontier. And the idea here is it says, look, take the very lowest expected return and say, what should our allocation look like for that number? Take our very highest return, what should our allocation look like to get this as our expected return? By the way, to be able to get this, what would the allocation look like? That's right, we would have to put all of our portfolio into the one stock because it's the only one that has that one. But everywhere in between then, we should expect to see some different kind of allocation. And that's what this is. We've got 11 different measures here where we're saying adjust the required return and build the model, and then save the weights. Adjust the required return, build the model. So the one other thing that we're going to have to do on this is that when we come to find frontier, because I'm activating the worksheet for the model, when we get to find frontier, I'm going to activate the frontier sheet here. Because for the chart to work the way this code is generating it, the frontier will have to be the active sheet. And all this code does is it says, from the worksheet, read the minimum and maximum return, and then make a loop that goes the number of times that the increment that you've set. So I'm only incrementing by 10% each time. And it just says add 10% of the difference to the minimum return each time, kind of give us a different level of required return. So now if I come back to my first sheet, my ticker sheet, and say process the model, it should go through, recalculate the model each time it adjusts the required return, and it should build then a graph that charts that frontier. And so this line shows how much risk I have to take on to be able to get a specific required return. And so this is a pretty tight bend in this frontier, but this means anything to the right of this line I could do. I could, at this expected return, I could take on more risk, but there's no reason to, right? I should take on as little risk as I can to be able to get that risk. So I really, wherever I am, I want to be somewhere along this line, right on the line. Because to be to the right of the line, I'm taking unnecessary risk. To get to the left of the line, I can't do it. There's no way to get there. And so that's the place that I'd like to be. I'm really not sure how I could talk about this stuff for 45 more minutes, but it must be that I used to, because this used to be the whole example for the class. What questions do you have on this? The thing about automating the solver is just to make sure that any changes that you make to it, you're starting from a blank solver. Make sure that you reset the solver before you then add things to it, and you should be in pretty good shape. Question? Is risk? Yeah, the risk is the expected return is here. So as I'm getting up to this 2.5% month over month expected return, I'm having to take on more risk to be able to get there. Yeah, so where do I want to be on this chart? I don't know, but I guess you finance people could probably tell me where the right place is to be. Probably. Yeah, as long as you're on the line, you're accepting more risk to be able to get there. I think as I'm going up here to get a little tiny bit more expected return, I'm taking on a lot more risk. I think personally for me, I prefer to be somewhere over here around about 45 where the slope of the line tangent to the curve at that point's somewhere around 45 degrees. That's my personal risk tolerance. I don't know. I'm not a finance guy. Question? The question is, do I use this for my investment practice? And the answer is no. I'm the kind of investor who says, okay, Mr. Broker, do this for me, and I don't want to think about it. I really don't want to think about it. Now, what I do want to think about is VBA code. And this was a really interesting VBA project. So, and it was more than hours. It was hours just trying to figure out how to put the equal sign in, right? So, and as I said, this used to be an example that we spent days and days and days on, probably 5 or 6 days building this, doing various, because it did the web query stuff, and it did the user form stuff, and it does the solver stuff. There's kind of a lot here. So it was really a fun example to build. And the truth is, the textbook I used to use took us partway down this road. So I wasn't starting from scratch. I would not know how to start this model from scratch. Other questions? Yeah, don't all get the data, but let me go ahead and run that. It takes a minute to do it because it can only make, it says, don't do this during class unless you place your own API key. I'll go, so you don't do it if you've got your own API key. So here it takes 12 seconds for each one, so it spaces out to get us 5 per minute. But it should go about 12 seconds and then pull in the first vector of data. So there's American Express, and it's actually bringing it into the Yahoo. I used to get it from Yahoo, but I left the sheet the same name. It's pulling it into the Yahoo tab, and then it's calculating the month over month change, and then it should pull the data in. Yeah, when I do that, it blows away all of the worksheets. I mean, it deletes everything except the tickers worksheet, and it builds everything up from scratch again. Almost as interesting as watching paint dry. Watch it come in. Ooh, what's next? Another question while we're waiting, sure.
So with Solver, that's one of the tools kind of automate it so it's a little faster. When it comes to like complex formulas and stuff, as a personal preference, do you think it's faster to just do it in Excel or figure it out in VBA?
Okay, so the question is, what about like some kind of crazy complex formula? Is that better to just leave in the cell, or better to do in VBA? Nice thing about doing it in VBA is that you can document it, right? You can say you've got lots more space to work with, and you can put notes and comments. You don't get comments in a cell formula, and so that's the nice thing. That the downside to doing it in VBA is that it's not automatic, right? Making one change doesn't automatically flow through. You would have to say regenerate, this sheet to go ahead and calculate it. How many of you have ever worked with a worksheet in Excel that was so big and had so many formulas that anytime you made a change to it, if you had auto calculation on, it would take upwards of 10 seconds? Just show of hands, more than 10 seconds to kind of recalculate the sheet by making a single change. It looks like about 10% of the class. That's not uncommon. And so when I get worksheets, and the truth is I don't often get worksheets that are like that because I don't really work with worksheets more than to program them, but that's when I start to say, you know what, maybe I should be doing some of this with VBA instead of doing it there. Now, the other thing that you might do is you might say, I could use this to kind of regenerate the worksheet. So I've got these complex formulas, and if I've got someone messing with them, I can just say, hey, regenerate this model and drop those formulas back in. That's probably less of a good reason to use it, because I think the right way to do that is to protect the workbook using the cell protection features that Excel has to kind of keep people from fiddling with them. Okay, so now it's re-pulled that data in. Thank you, no one, for running that at the same time as me. Otherwise, it would have come back with an error here, but looks like we got them all. And we should be able to hit the next one, process the model, and it should go through and rebuild that same stuff again. You can kind of see it working through it here, and it's built that frontier again. Probably should have changed the stock. Should have dropped Southwest Airlines off. But there we go. Other questions? All right, that's it for the solver.